Alright, so this video is for the second part of section R5. We're dealing with rational expressions here. We're dealing with adding and subtracting them, which seems like it should be easier than multiplying and dividing, but it's not. It's actually the reverse. Adding and subtracting is always so much harder when dealing with fractions. If I were to multiply these two fractions, it's pretty simple. I can reduce things upstairs and down and then multiply across, right, the two fractions. But here for adding, I can't just add the tops, right? I don't say this is not 7 over 12, right? We don't add fractions that way. We have to get a common denominator. And so the least common denominator in this case, because there's no common factors among the 5 and the 7, we can just multiply those together. Now, that process of multiplying the denominators together will always get us a common denominator, but it will not get us the least common. And so we're starting with simple, just fractions without variables to help you see the process, but we will eventually get to rational expressions that deal only with variables. Okay, so 35 is the LCD, so we turn each of these into the LCD. So remember, we multiply the top and bottom by whatever we need to make that denominator 5 into 35, so 7. So we multiply top and bottom by 7, so that becomes 28 over 35. And then what do we multiply the 7 by to get 35? We got to multiply the top and bottom. We're essentially getting, you know, these fraction families that you learned in earlier in your math career. So I multiply top and bottom by 5. That will give me 15 over 35. So I turn these two fractions into equivalent fractions, right? And now I'm simply going to add the numerators because the denominators are the same. So that gives me 43 over 35. And then at this point, we would reduce this if possible. 43 is prime, though, so no, there's not going to be any numbers that divide both into 43 and 35. All right, so this would be our final answer. But getting an LCD is kind of the first step. So in this part B, what is the LCD? So I could multiply these two together and get 48, but that would not be the least common denominator. It would just be a common denominator. And it would make the problem so much more difficult and at times impossible to do. If I, when we get to variables, it'll be much, much more difficult. And it'll give you answers that don't really exist. So what we want to do is the least common. And so I think most of you can look at this and say, oh, well, the least common denominator is obviously 12. Okay. And so now I got to make both of them into 12. So I multiply this by 3 and I multiply this by 3. So we get 15 over 12. So 5 fourths is the same as 15 twelfths. And then plus, this one's already the correct denominator, so I don't have to do anything to the second fraction. I simply add those up. That's 22 over 12, but now I need to reduce this because there's common factors in there. So we reduce that, and that becomes 11 over 6, and so that is our answer. All right, now those two are pretty easy because you can just look at these and say, oh, the least common denominator is 35. The least common denominator here is 12. This one's a little trickier, right? So I gave you a little bit bigger numbers here in part C, and so that we can use the process. This process that we're going to use on this one to find the LCD is the process we're going to use once we start talking about variables, introducing variables into the thing. So what you want to think about is think about those denominators as prime factorizations. So take 18 and write it as all of its prime factors. So 18, that's 9 and 2, but 9 is not prime. It can be written down as 3. So I'm going to say 3 squared. So I'm going to say 2 times 3 squared is the way you would write 18 in its prime factorization. Okay, and so we want to do the same thing with 24. So 24, that is what? 8 times 3. But 8's not prime, so we break that down into 2 times 2 times 2. So 2 cubed times 3. Okay, so here are we've written these fractions with the denominators as their prime factorizations. Okay, now how do we find the LCD? The LCD. So the LCD is going to be made up of any factor that's in any of the denominators. So I know there's going to be a 2 and I know there's going to be a 3 because those are those show up. So I know I get a 2, and I know I have a 3 as part of my LCD. However, I got to figure out what power to raise it to, right? What power to raise this to. So it's going to be the highest power that this 2 has in either or all, might be more than 2 denominators we're trying to do, but the highest degree that it exists in any of the denominators, and so that's clearly a 3. So I'm going to put 2 cubed. And then what's the highest that 3 has? Here it's a 1, and there it's a 2, so that's going to be a 2. Okay? So yes, that is going to be 8 times 9, that's 72. But probably easier to think of it leave it in terms of the prime factorization right now, because, well, you might not, you might have to think a little bit, like, what times 18 gives me 72? Well, look at the prime factorization. So what times this prime factorization gave me this prime factorization? And so you can see that we already have the 3 squares in there. We have a 2, but not enough of them. We need 2 more 2s. So we're really going to multiply this top and bottom by 4. So that's going to be 4 over 72 for the first fraction, plus, and then what times this prime factorization gave us this prime factorization. We already have enough 2s. We need another 3. So I'm multiplying top and bottom of this thing by 3. So we get 3 over 72. Does that make sense? I mean, you could certainly say, oh, 72 divided by 24, that's 3, but that takes a little work. So it's a little bit easier sometimes if you leave it in terms of the prime factorization. So finally, that's 7 over 72. All right, so now the reason we did these sort of simpler examples without any variables in it is because the same process is what we're going to do down here with these things. All right, so let's look at example 2. All right, so we want to think of the prime factorizations to find. First thing we always do is we look for the LCD. Okay, so so this 6, that's a 3 times a 2, and this 9, that's 3 squared. So I know, as far as the coefficients go, I know there's going to be a 2, and I know there's going to be a 3. I know there's an A, because it exists in one of them, A, and a B, because it exists in at least one of them. Okay, so I know those are the things that make up my least common denominator. Now, do I need any powers other than 1 on those? So look at 2. 2 exists in one of the denominators, and it only has a power of 1. So that's going to be left with a power of 1. Now, I normally wouldn't bother putting the 1 in there, but I'm just emphasizing that. All right, 3. 3 has a power of 1 here and a power of 2 here, so that's going to be a power of 2. Okay? A has a power of 1 here and a power of 2 here. It's the highest one, so 2. And then B has a power of 3 and a power of 2, so that's going to be a power of 3. Okay? Now these numbers are simple enough, so you could rewrite this and say, oh, the LCD is what, 18, right? You could do that if you want. Sometimes it's easier, again, like we did over here, it's easier to think of it in the prime factorization and compare those. But, so this one has, what, a 3 and a 2 already. It just needs, what, another 3. But, 3 times 6 is 18, so that one's probably easy enough to do on your own. So, let's see, we have 2 fractions of them. The bottom of this one became 18, a squared b cubed, and so does this one, 18 a squared b cubed. All right, so now what did I have to multiply this denominator by to make it into this, right? So we needed another 3, so we're going to have a 3. And then what about the a's? We need another a, and we don't need any b's. So it's 3a times what was up there. Here, over on this example, we did 4. We really did 4 times 1, but we just wrote down the 4, right? The 1 was up there. 3 times the 1. So here we have something other than just a 1 up there. So we have an x. So we have 3a times x. So what we did is we multiplied top and bottom of this fraction by 3a. That's what we needed to multiply the denominator by, the denominator here by, to make it into the LCD. All right, so we have 3a times the x. And here, what did I need to multiply this by to turn it into the LCD? I need a 2. All right, so a 2. There's enough a's already in there, but I need another b times the 4y that's up there. Okay, so kind of running out of space a little bit here, but so that's going to be 3ax. I'm going to write it now as one fraction because the whole point is get the denominators the same, and now I can just add the top. So the top is 3ax plus 8by. And then on the bottom we have 18a squared b cubed. Okay, so we get the denominators the same, and then a common mistake I see is people write this with two denominators and they say, oh, I can cancel this 8 and this 3. Well, you could, but then you no longer, then that would be a 6. This would be a 1, and you're going back to kind of what you had, right? So now the denominators aren't the same. So resist that temptation, right? You turn everything into LCD and say, oh my gosh, look, I can cancel this 18 and this 2. Yeah, you could, but then you no longer have 18 and 18 down the bottom, which you have to have in order to be able to add these things. Okay, let's go on to the next one. All right, so we need, here we did the prime factorizations of the coefficients, but here we want to factor the denominators. So make sure that you're factoring those out. We're not worried about factoring the numerator, only the denominator. So yes, you could take a 2m out of the top, and I would do that if I could cancel with something in this term right here, but that doesn't look like that's going to help. So we're going to not factor the numerators generally, just the denominator. So I'm going to pre-factor it here so I can see it's going to be a 5m plus n. And I'm going to factor a 3 out of this, and I get an m plus an n. Right, now I can think about the LCD. All right, so the LCD, any factor. Now the factor, like we saw up here, these different factors were in a monomial, but here the factor is a binomial. Right, so we had an a and a b and like we had a 6, which is a 2 and a 3, and an a and a b. Those were a monomial. Here we have a binomial. So one factor is a monomial 5. The other factor is a binomial m plus m. So I know I'm going to have a 5. I'm going to have an m plus n. I'm going to put that in parentheses. Here I also have a 3. So I have that, and I have my m plus n already. Everything is to a power of 1, so I don't have to square anything. So let's rewrite this. This is 15 m plus n. Now you want to leave it in factored form. Don't, say 15 m plus 15 n. Not yet. Can, that is equivalent, but leave it in factored form while you're working with it because you want to see if you can cancel anything at the end. Okay, so what do I need to multiply this denominator by to make it into this denominator? Or if you want to look at it this way, you can do it that way too. 3. So I'm going to multiply top and bottom by 3. So that is going to give me the top plus times. So let me write it over here. 4m plus 2m. Well, why don't we combine this? We can simplify that, right? They're the like terms. So we can say 6m that was there, and then we multiply top and bottom by 3. Okay? Over 15m plus n plus, and now I got to multiply this denominator by 5 and in order to make it 15m plus n. So I'm going to multiply the top by 5 as well. So 2 times 5, and then on the bottom 15m plus n, that's in parentheses. Okay? Now normally I will skip over this step because I can kind of add, I can multiply these two things and add them. So kind of, at some point you want to skip over this step just to save yourself some time and writing. So so that's going to be what? 18m plus 10 over 15m plus n. Now I wrote it like this in factored form down below because sometimes I might need to cancel something, right? So is there a common factor here? There is. There's a 2 is a common factor. But that 2 isn't going to cancel. So if I wrote this as 2 9m plus 5. That's not going to cancel with anything downstairs. Okay, this 2 doesn't cancel with the 15. So we would want to factor this top if it can cancel with things down below. And that's why we leave this in factored form down below, because if this was like, oh, if we were able to factor out a 3 here, then we would have to cancel the 3 with the 3 and the 15. So we have to look for factors in the top to see if they cancel with the stuff down below. But in this case, it doesn't. So we don't really need to worry about factoring that top. We just really need to simplify the bottom. So we're final best answer, 18m plus 10 over 15m plus 15n. And so again, resist the temptation to cancel these things, right? There's a 3 in here and a 3 in here, but those are parts of binomials, and we can't cancel them. Can't cancel the m, can't cancel the m, can't cancel the 5, that would be in the 10 and the 15. Again, this is your best final answer. All right. All right, let's move on. All right, number 4. Now these are all monomials this time. So first come up with the LCD. All right, so we know there's a 3. This 6 is 3 and 2, so I know there's going to be a 2. And the 8, that's 2 cubed, so I have a 2 in there already. So I'm just going to write down everything that's going to be in there. I know an A is going to be in there, and I know a B is going to be in there. All right, now, what power? Do I need to raise anything to any other power? This is just 3 to the 1. This will be a 3 times a 2, so still 3, and there's no 3 here, so just a 3. 2, there's a 2 here, but there's 2 times itself 3 times here, so this will be 2 cubed. All right, A's, this is to the 1, this is 3, this is, so 3. And then B, what's the highest it shows up? Squared. Okay? So if you wanted to think of that 3 times 8, that's 24. So if you want to think of that as 24, A cubed B squared, that's fine. 3 times what is 8 is 24, that's 8. So I'm going to have the 4 that's up there, and I'm going to multiply it by an 8. And then what variables do I need to multiply it by? Looks like A squared, A cubed. Okay, this time I'm going to write it all as one fraction, because, you know, I hope we're kind of getting to a point where, like, okay, I could write it as 3 separate, but then I'm going to write it together in the next step. So I'm just going to go ahead and just know that I've got 24a cubed b squared in the denominator. Okay. All right, what times 6a cubed gives me 24a cubed b squared? That's going to be what? 4b squared. So we have the 1 times 4b squared. And then this plus really should be moved up to the negative. So you remember that there's going to be a negative there, negative 3 times, and then what? What times this 8ab gives me this? That's going to be a what? A 3 a squared b. So 3a squared b. Okay, and so let's rewrite that now, simplifying the top. That's going to be 32a cubed plus 4b squared minus 9a squared b all over 24a cubed b squared. So that is your, I think, best and final answer there. There's nothing common to everything upstairs that we could factor out and cancel with 24. This is an 8 and a bunch of 2's, right? This is 2's, but this is 3's, so no common factor in there to pull out. Okay, so best final answer there. Next one. Instead of thinking of this as 3 terms, it might be nicer to think of this as like that, which works just the same. So think about the LCD. LCD, it's the two denominators, right? So it's just x plus 2, which is the factor in this one denominator. All right, so I got to turn this into x plus 2, so I got to multiply top and bottom. So that's going to be x plus 2 quantity squared plus 1, because that denominator is already the same, and let's just write that as x plus 2. Let me shorten that fraction a little bit so I have a little more room to work. And then what's this going to be? This is going to be we can simplify that. That's x squared plus twice the product, 4x, plus 4, but plus this 1, so let's say plus 5, over x plus 2. Now, are we done? Well, you got to be careful. This is a trinomial. If that thing were to factor, if this trinomial were to factor into two binomials where one of them is x plus 2, then we would need to cancel those. But I think you can see that neither one of these could be a 2 because this is a 5. So it might factor, but we don't care because we only care if this factors into something that we can cancel with. We don't want to leave it in factored form. We want to leave it in simplified form. So that is the best answer for that one. All right, next one. Think about what the LCD is. You might pause the video and try this problem. All right, so really, these are really the same. We don't want to put both of these in to our LCD, right? Remember, they're not conjugates. This one can really be thought of as x minus 3 with a negative in front. So that, so these aren't different. So factors that differ by negative signs don't really differ, is what I'm trying to say. So really, it's just x minus 3. What we want to do is we want to move that up above. So we want to make this negative, this positive, and move the negative up to the 4. Does that make sense? And then we really have x minus 3 here, right? So that's really what we're going to do. We're going to think about factoring a negative out. Remember, these aren't conjugates. They differ. They're different by a factor of negative 1. And so we never put a negative 1 in our LCD. Ones don't go in there. Neither do negative 1s. So we've already made now the LCD, the denominator is the same. So really we can just add these. So this is negative 2 over x minus 3. Much easier than if you had tried to use these both in here and said x, if you had done x minus 3 times 3 minus x, that makes the problem so much more complicated. You don't want to do that because those are not different factors. Okay, they're the same factor. They differ by a negative 1. So as far as LCDs go, they're the same. All right, next one. Find the LCD. Again, pause the video, try it on your own. Here I'm going to factor the denominator. This is a difference of squares, so x plus b, not x plus b, sorry, a plus b and a minus b. And now the LCD is just the binomials, right? A plus b, that's going to be in there. A minus b, that's going to be in there. And now a minus b, that's already in there. A plus b, that's already in there. So this is the LCD. All right, so we're gonna multiply top. You don't have to multiply this by anything because the bottom is already the LCD. So we have a squared plus b squared, and I'm going to say a plus b and the quantity a minus b on the bottom here. Okay. Now here, what are we going to multiply this by to make it this? Well, that's a plus b. So I multiply the top by a plus b, and I multiply the bottom by a plus b, and that's what gives us this. All right, here, what are we going to multiply by? We're going to multiply by, now careful, this is a common mistake. Instead of a subtracting, I'm going to say plus, and I'm going to move the negative up, because that negative b has got to be distributed into what I'm multiplying top and bottom by, which is a minus b. And that right there is where people make mistakes. They forget that this negative gets distributed in there, right? They just see the b and they forget that there's a negative out in front. So be careful with that. All right, so we get, As we have a squared plus b squared. Distribute that. That's plus a squared plus ab minus, well, ba, but let's write it as ab so we see them as being the same. And then plus b squared. So the ab's cancel, and we have 2a squares and 2ab, so we have 2a, I kind of skipped over the denominator there, just working on the numerator, that's kind of being sloppy there. 2ab plus 2b squared, no, sorry, 2a squared plus 2b squared over, and then really, this isn't going to factor, right? We could factor a 2 out and leave it as 2 times a squared plus b squared, but that's not going to cancel with anything in our denominator. So let's go ahead and just simplify that denominator. That is a squared minus b squared. Okay, and remember, again, this kind of looks tempting, like you should be able to cancel the b's and cancel the a's, but you cannot because these are binomial. All right, let's go on to number 8. Find the LCD there. Again, pause the video, try this on your own, then come back and look at the video. All right, so the LCD, in order to find the LCD, I'm going to have to factor these. So factor this denominator. I'm going to sort of pre-factor it here. And so that's x, and that's, what are we going to be? Minus 4 and plus 3. Sorry, plus 1. All right, and so that difference is negative 3x. So that seems like it works. All right, so every denominator, every factor that's in a denominator is going to be in our LCD. So I know I have x minus 4. I know I'm going to have x plus 1. I already have the x plus 1 in there, so I'm not going to put it in again. I have the x plus 1 already in there. Now, to what power do any of these need to be raised to? That x plus 1 must be squared. Okay, so that means I'm multiplying to get this denominator to be this. I'm multiplying top and bottom of this fraction by x plus 1. All right, so that's x minus 1 times x plus 1. And let's do this whole thing. Now again, I'm going to move this negative up to the 5, so I remember to distribute the negative with the 5. So negative 5, what do I need to multiply this by to make it that? Well, two things, x minus 4, x minus 4, x plus 1. And then the plus 2, what do I need to multiply this by? Just the x minus 4. Okay? And sometimes, so I don't have to keep rewriting that, I'll cheat. As I'm working through the problem, I'll just say, oh, LCD, just to save myself a little time. Okay. Let's simplify this. This is going to be x squared minus 1. Now be careful of this. I'm going to FOIL it, but I'm also going to distribute the negative 5 to the result. So I get x times x, that's x squared, so negative 5x squared. And then the outer is going to be x. The inner is going to be negative 4x. So that's negative 3x times the negative 5. So that's positive 15x. You might take a couple steps to get there, but I'm doing it in one. So this is negative 4, right? The last two things, times a negative 5. That's going to be positive 20. All right, so it's safest if you FOIL these first and then distribute the negative 5 into those three things. I did it all at once. Okay, so plus 2x minus 8. All over, again, I'm just going to cheat and say LCD for now to save myself some space and some time. Now I want to combine like terms. All right, let's see. X squares. I have 2x squares, two of them that are x squares. That's negative 4x squared. Let's go to the x's. That looks like 17, so plus 17x. Constants, I have what? A 1 and a negative 1 and a negative 8 and a positive 20. That looks like positive 11. over now the LCD. Now, I normally don't, I don't simplify this out, or I factor this in checking to see if something would cancel with the LCD, which is this up here. But this will not factor, right, as it turns out. So now, also, simplifying means getting rid of parentheses, but if you have three binomials, because that's what this is, right? One binomial, and then there's two of them here. So I would say, go ahead. Our book often doesn't simplify the denominators when we have multiple binomials, and I'm okay with that too. So if it were two binomials, like this one was two binomials, that's easy enough, simplify it. But if you have more than two, if you have three or more, I'm okay with you leaving that as your answer. Okay. All right, let's go on to page 3. Page 3. So this is a little bit different than what we were doing with these. We were adding complex fractions, but here we have what's called we were adding rational expressions on that last page, but on this page we are dealing with what we call complex rational expressions. So essentially it's a fraction made up of fractions. So it's not just a polynomial over a polynomial, but it's a rational expression over another rational expression. All right, so we think of this as 1 over x divided by y, and we want to think of that as y over 1. Now, we can certainly do the whole keep, change, flip thing, right? And so I'm going to teach you a couple different ways, two different ways of doing this. So I can certainly say this is 1 over x. Instead of dividing by y over 1, I'm going to multiply by the reciprocal 1 over y. And so then this is just 1 over xy. Because we're multiplying, we just multiply the tops together, we multiply the bottoms together. All right, another way of doing this, and it's not going to look like it's that much easier here in this simple problem, but it will be much easier when we get to the more complex ones. So think about think of this as over 1. Think about all the denominators. So we have upstairs, we have the denominator of x. Downstairs, we have a denominator of 1. What is the LCD of all of the denominators? And I think you can see that's x. And so what I can do is multiply the top by x. So 1 over x gets multiplied by x, and the bottom, x over 1, gets multiplied by x. And I can do that because x over x is just itself, right? It's just 1, I mean. And so, so we can do that. Like, it's a little trick. And so what happens upstairs when I multiply 1 over x by x, that just becomes 1. And what happens when I multiply y over 1 times x? That's just xy. So you can see you get the same answer. This tends to be a little bit faster. Now, it didn't seem to be much faster here, but it will be in these problems down below. Okay. So think about the LCD. So think about all the denominators. So 12 and 3 and 3 and 2. What is the LCD of those 4 denominators now? And so I think you'll see, if you think about it, the LCD is 12. So now what I'm going to do is multiply by 12 over 12. So remember, I'm distributing this 12 into both those fractions. All right. So 1 over 12 times 12, that's just 1. 12 times negative 5 over 3. Well, the 3 and the 3 is going to cancel with the 12 and leave me with the 4. So that's just 4 times 5, which is 20. All right, I'm canceling these out, and then the result gets multiplied by the numerator, right? So 12, remember, I'm not multiplying both of these things by 12. Just the top gets multiplied by 12. But rather than saying 12 times 5, that's 60. What's 60 divided by 3? That's 20. It's easier to say, oh, 3 cancels with the 3 and the 12 and gives me 4. 4 times 5 is 20. Okay, that's just a little faster. All right, what happens here? So 1/3 times 12, that's just 4. And then when I cancel the 2 with the 2 and the 12, that leaves me a 6 here. 6 is left to multiply the 5, that's 30. So plus 30. Okay. Now, I went through and explained all that. I mean, if I was doing this, it would take me 2 seconds to do this. This is really quick. And so now what do we have? We have negative 19 over what, 34? Okay. Now, in order to do this the old way, it wouldn't be a bad idea. I'm just not going to do it that generally the old way, but we have 1 over 12 minus 20. Oh, we would have to get common denominators, right? So common denominator on the top would be a 12, so that would, I'd have to multiply top and bottom by 4, so that would be, this, right? That's what you would be doing. On the bottom, the common denominator is going to be 6. That's going to be 2 over 6 plus, and then we have to multiply this by 3 over 3, so that's 15 over 6. And then we would add these up. That's negative 19 over 12 divided by what is that, 17? Wait, something's wrong. 1/3. No, that's right. 17? Oh yeah, 17 over 6. Yeah, over 6. Okay, and then we want to do a keep change flip. So we have negative 19 over 12 times the reciprocal 6 over 17, and then we would reduce. Oh, sorry, you can't see that. Then we would reduce the 12 with the 6. That's a 1 and a 2, and so that would be, if we multiplied across, then negative 19 over 34. So that's just a little bit more work. All I did was multiply by 12 over 12, and it was much quicker. All right. Try number 3. All right, now be careful with these. This negative 1, right? That means, remember the negative exponent. If I had 2 to the negative 1, that's equal to 1 over 2. Right? So if I have x to the negative 1, that's equal to 1 over x. Right? Remember what the negative exponent does? All right, so be careful with this. Because of this plus sign, when I try to get rid of this negative exponent and bring the x downstairs, it doesn't come down here. This is what it becomes. It's 1 over x, right, on the top fraction, the top, and then plus 1 over y. And on the bottom, it's, careful, what would that be? 1 plus, the x stays where it is, the y goes downstairs, so x over y. All right, so now think about what the LCD is. The LCD, I have an x and a y. If we want to think of this as a fraction here, instead of 1, it's 1 over 1. So the denominators are x, y, 1, and y. So I'm going to multiply by xy over xy. All right, so when I multiply this first fraction by xy, the x's cancel, leaving me with just y. When I multiply xy by 1 over y, the y's cancel, leaving me with just x. Over on the bottom, it's going to be xy, and then plus, and then you see here the y's will cancel, leaving me with the x times the x, or x squared. All right, so that looks good. Only issue here is there is a common denominator on the bottom, so we have so y plus x, I guess, and then on the bottom I'm going to take an x out, and that leaves us with y plus x. So the y plus x's cancel, and this just leaves me with 1 over x. Okay. All right, let's move on to example 4. Getting a little more complicated, but you can see what are the LCD. So the LCD for this one is x minus y and x plus y. All right, so that's what I'm going to multiply. This fraction gets multiplied by x minus y, x plus y, and x minus y, x plus y. All right, so what's left? When I multiply this fraction by these two things, the x minus y cancels with the x minus y, leaving me with just this x plus y times the x. So on top, I have x times the x plus y. All right, then on the next one I have a y, and then the x plus y is canceled this time, leaving me with the x minus y times the y. All right, on the bottom, similar thing happens. The x minus y is canceled down here, leaving me with x times x plus y, and then minus, and then the y upstairs, right, the y, and then the x plus y is canceled, leaving me with x minus y. All right, so now I need to just simplify all that. I get x squared plus xy plus another xy minus y squared. On the bottom, I'll get x squared plus xy minus an xy and plus y squared. All right, so let's combine like terms. This is on top x squared plus 2xy minus y squared. It looks sort of like a perfect square trinomial, but this is a negative instead of a positive. And then on the bottom, we get the xy's canceled. We get x squared plus y squared. Now it feels like, and so this would be our final answer, it feels like we should be able to cancel things sometimes, but we can't because these are parts of polynomials, not monomials. And the bottom doesn't factor, the top doesn't factor, so there's no way to cancel anything else out. All right, next one. This one's really easy, and you'll see things like this next year in Trig Calc, so that's why it's good to be practicing some of these. So we want to think about the LCD of all the denominators. So 1, x squared, x, and 1 is the denominator there. So x squared. So I'm going to multiply by x squared over x squared. So pause the video and try multiplying that and see what you get. All right, so pretty quick, you're going to get what? X squared for the first term. One of these x's is going to cancel with one of these x's, leaving one x left behind, so times the 2. And then the x squares totally go away, so we get 3. Over, same kind of thing here, one of the x's cancels, so we get 4x, and we get plus, nothing cancels here, that's 2x squared. Now, we should check to see if maybe this were to factor into something, right? I could take, what could I take out? I could take, let's rewrite this with the 2x squared in front. I could take a 2x out, and that would be x plus 2, right? And so if the top were to factor into one of the binomials that the top factors into, if it factors at all, into x plus 2, then we would need to cancel it. But I know this 3 isn't gonna give me a binomial with a 2 at the end. So I know even if these things are factorable, they don't factor into things that will cancel, so we don't have to worry. So leave that alone, and this would be then the best and final answer. All right, last one. Think about the LCD there. If it helps, think about this is over 1 and this is over 1. So clearly, I think you can see it's square root of 3 divided by the square root of 3. It's going to be the best way to do that. When I multiply this by that, we get square root of 3 plus 2. The square roots of 3's are going to cancel there. Here we get, I think, what, 3 minus 1. And then we just want to simplify that. And maybe put the 2 first. 2 plus the square root of 3 over 2. All right, and again, don't cancel those 2's. That doesn't work. This is a monomial. This is part of a binomial. Cannot cancel those. All right, and that is your last one there. So that's just a quick way to simplify these complex fractions or complex rational expressions. All right, and so your homework for the second part of R5 is listed here. Okay, again, E is even. So 50 through 88, the evens, and then 91 and 92.